Hello there. So in this video we're going to look at the initial value problem y triple prime minus 7y prime minus 6y equals negative 42e to the negative 4t with these initial values listed at the bottom. In order to solve this, we will need to get the general solution, where we need to find y sub c of t, which is the solution to the homogeneous equation, and a particular solution, which is solving the non-homogeneous for a particular solution of this form. So first we look at the homogeneous equation, and we know for the homogeneous equation we have y equals e to the rt as that form there, taking the derivative 3 times to get to plug into the differential equation to get the characteristic equation, r cubed minus 7r minus 6 being equal to 0. This characteristic equation, we do want to factor it so we can get all the values of r. We can guess a solution, r being equal to negative 1. If we do that, we can see that negative 1 minus 6 is negative 7, plus 7 will equal 0. So that's one of the solutions. We can use synthetic division to help us find the coefficients of the corresponding factor to r plus 1. So doing that, negative 1 times 1 is negative 1. Negative 1 times negative 1 is 1. Negative 7 and 1 is negative 6. Negative 1 times negative 6 is 6. Adding that is 0. So now we have all we need to factor the polynomial, knowing that r plus 1 is a factor times r squared minus r minus 6, and that's equal to 0. And r squared minus r minus 6 factors nicely to r minus 3 times r plus 2. And this is wonderful because now we can write our solution y sub c of t using the values of r, which are going to be negative 1, 3, and negative 2, and they're all going to be independent solutions of this form, e to the rt. So I will write that right now. C1 e to the negative t plus C2 e to the 3t plus C3 e to the negative 2t. I'm going to highlight this. So now that we have y sub c of t, we just need to find a particular solution from the non-homogeneous equation, and that is going to look like the form of the right side of the equation. So y sub p is going to be equal to some constant a times e to the negative 4t. We do need to take the derivative a few times, plug those in. So negative 4a e to the negative 4t, y double prime 16a e to the negative 4t, y triple prime negative 64a e to the negative 4t, and plugging those in. Negative 64a e to the negative 4t. Notice here it's y prime. We don't have a double prime, so we can ignore that. Plugging that in, we end up with plus 28a e to the negative 4t and minus 6a e to the negative e to the negative 4t. Summing all the left side terms, we end up with negative 42 e a times e to the negative 4t, and that is equal to negative 42 e to the negative 4t. This just means that negative 42a has to be equal to negative 42, which means a equals 1. So that gives us our particular solution, which I will write right here, and that is equal to e to the negative 4t, since a is equal to 1. And I'm going to highlight that. So now we have our general solution, which is y of t being equal to y sub c of t, which is c1 e to the negative t plus c2 e to the 3t plus c3 e to the negative 2t plus e to the negative 4t. And since this is an initial value problem, we do need to plug our initial values in. Our first one is y of 0 being equal to 4. We'll need to take the derivative because we are given y prime of 0 is 2. And the second derivative as well. And y double prime of 0 is 52. And taking the derivative of our function, negative c1 e to the negative t using the chain rule, plus 3c2 e to the 3t minus 2c3 e to the negative 2t minus 4 e to the negative 4t. Second derivative is just going to be, again, using the chain rule, positive c1 e to the negative t plus 9c2 e to the 3t plus 4c3 e to the negative 2t plus 16 e to the negative 4t. Now we can plug in our initial values to get equations with just C1, C2, and C3. So doing that now, we have 4 being equal to C1 plus C2 plus C3 plus 1. And I am going to get all the terms, or all the variables on one side and the constant on the other. So this would become 3 being equal to C1 plus C2 plus C3. Next, y prime of 0, we know is equal to 2. That will equal negative C1 plus 3C2 minus 2C3 minus 4, which, when you get the constants on the other side, becomes 6 being equal to negative C1 plus 3C2 minus 2C3. And lastly, the second derivative, y double prime of 0 is 52, and that will be equal to C1 plus 9C2 plus 4C3 plus 16. And again, bring in the constants all on one side. That will give us 36 being equal to C1 plus 9C2 plus 4c3. Alright, so now we have our system of equations where all we need to do essentially is find C1, C2, C3 equal, and then we will have our solution to the initial value problem. We just plug it into the general solution. So, to make this as easy as possible, I notice the first two equations, if I add them together, the C1s will cancel out. And similarly, if I add the second and third equation. So I'm going to do that, and that will leave me with two equations with only C2 and C3. So adding the first two equations will give me 9 being equal to 4c2 minus c3. Adding the second two equations gives me 42. C1s cancel out. 12c2 plus 2c3. So now we have two equations with just C2 and C3, and that's nice because now I can get rid of the C3 if I just multiply the second equation by 1/2. When I do that, I'm going to rewrite these over here. 9 being equal to 4c2 minus c3. 21 being equal to 6c2 plus c3. Adding that together, we end up with 30 being equal to 10c2. So c2 will be equal to 3. Which in turn helps us figure out what C2 is. We know not what C2 is. We know what C2 is. C2 is 3, so 4 times 3 minus C3, though. We can find C3. That's just going to be 12 minus 9, which is 3. And lastly, C1 is just going to be 3 minus C2, which is 3, minus C3, which is 3. So C1 will just be negative 3. And we are almost done. All we need to do is just write our solution to the initial value problem now that we know our C1, C2, and C3. C1 is negative 3, so it's going to be negative 3 e to the negative t plus C2, which is 3, e to the 3t plus C3, which is also 3, e to the negative 2t plus e to the negative 4t. And that is our solution to the initial value problem.